Okay, let's solve a problem using Reynolds number. So we have a fluid that has a viscosity of 0.38 newtons second meter squared, specific gravity of 0.91. It's going through a 25 millimeter pipe. It's got a velocity of 2.6 meters per second, so we need to calculate out the Reynolds number. Now I've already written out the pertinent information from the problem. There's our viscosity. Here is our specific gravity of 0.91. That little symbol is the diameter symbol, 25 millimeters, and there's our velocity of 2.6 meters per second. So let's write out what is our Reynolds number equation. Well, Reynolds number is either density, velocity, characteristic length over viscosity, or it's velocity, characteristic length over kinematic viscosity. So we're dealing with a pipe diameter, so across the diameter is where the interesting stuff happens. So that'll be our L. We have V, but now we need to calculate out either mu or our density so we can solve things. So the first thing that we need to do is we've got that specific gravity, and we know from before specific gravity is density over density of water at 4 degrees C. So we can rearrange that equation and know that our density is our specific gravity times density of water at 4 degrees C. So density is just going to be 0.91. We're in the metric system. Water at 4 degrees C is 1,000 kilograms per cubic meter. That gives us a density of 910 kilograms per meter cubed. So now I can sit there and I can plug that in with my viscosity and find the kinematic viscosity, or I'll just go right to the equation, plug everything in. Reynolds number, viscosity, 910 kilogram per meter cubed. Our velocity is 2.6 meters per second. Our kinematic viscosity, our characteristic length is the pipe diameter, which is 25 millimeters. We need to convert that to meters because it's a dimensionless parameter. Everything needs to cancel out. So I've got 1 meter is 1,000 millimeters. And then we're going to divide that by our kinematic viscosity of 0.38 newtons per second meters squared. So let's first make sure all the units cancel out, because it should be a dimensionless parameter. And so as I'm looking at things, there's a kilogram, there's a meter, and there's 1 second, there's another one. So that gives me kilograms meter per second squared, which is a newton. And then those newtons will cancel out. So my millimeters cancel out. 25 millimeters. And so I'm left with meters over meters cubed over meters squared. And so that cancels. And so I've got 1 over meter squared, 1 over meter squared. All of my units cancel. That gives me a dimensionless parameter I'm very happy with. And if I bash the numbers, that gives me a Reynolds number of 156. It's very important that this is a dimensionless parameter.